Good morning. Our today's module is energy systems, module number 3. We are going to start with energy systems. The topics which we are going to divide or discuss today are chemical fuels, calorific value. Chemical fuels are classified into various types depending upon physical state and occurrence. So we're going to discuss the classification of chemical fuels and the parameter, how much energy is obtained when the fuel is burnt, that is obtained by calorific value. We're going to discuss what is calorific value, types of calorific value. Let us discuss these topics one by one. What are fuels? So fuels are chemical substances which contains carbon and hydrogen as its main constituents. So in general, we have so many substances undergo combustion. Can we call all the substances a chemical, or can we call all the substances a fuel? No. Can we call this mask? This mask undergoes combustion. Right, when we light it, it undergoes combustion, but we cannot call it as a fuel. This paper undergoes combustion, isn't it? When you light the paper, this paper undergoes combustion. Can we call it as a fuel? No. But when this tie undergoes combustion. When you light it, it undergoes combustion. This mouse undergoes combustion. Can we call it as a fuel? Your chair, your fan, when you light it, undergoes combustion. So it will burn. So anything that burns, can we call it as a fuel? 100% no. So there is some criteria for each and everything for which we can call it as a fuel. So what is that basic criteria? Let us see. So any chemical substance to be called as a fuel, it should mainly contain carbon and hydrogen as its main constituents. So any chemical substance which contains carbon and hydrogen as its main constituents and on combustion produces significant amount of light and heat, certain type of substance only are called as chemical fuels. I repeat, any substance which contains carbon and hydrogen as a main constituent and on combustion liberate significant amount of light and heat, that is energy in the form of either light or heat, are called as chemical fuels. So for instance, what type of reaction occurs? So chemical substance contains carbon and hydrogen. So it's mentioned in the reaction over here, carbon, hydrogen. So in presence of oxygen, carbon becomes carbon dioxide, hydrogen becomes water, energy will be liberated. So energy might be in the form of carbon dioxide, or energy might be in the form of light, or energy might be in the form of heat. Right. So carbon present in the fuel, it's converted to carbon dioxide. Hydrogen present will be converted to water, and energy will be liberated either in the form of heat or in the form of light. So examples. So you have n number of examples, right? So you have wood, coal, charcoal, petrol, diesel, kerosene, etc. So you can take in the form of gas. You have LPG, natural gas, CNG, that is compressed natural gas. So you have n number of examples for fuels. So now let us see the classification of the fuels, how the fuels are classified. So fuels are mainly classified based on their physical state and based on their occurrence. So based on physical state. So what do you mean by physical state? So how would they appear, right? So physical state means how they appear. So depending upon the appearance, we call whether it is a male or a female, isn't it? So similarly, depending upon how they look, they are classified into three types. One is solid fuel, liquid fuels, and gaseous state. So simply depending upon their appearance, fuels are classified as solids, liquids, and gaseous fuels. So example for solid fuels, your wood is a solid fuel, your peat is a solid fuel, coal is a solid fuel, charcoal is a solid fuel. So any solid fuel, your wood, coal, charcoal, peat, lignite. So your lignite and peat, these are allotropes of coal, right? So charcoal, you know how it is obtained. So the remains of incomplete combustion of wood, you get charcoal. So charcoal is also a type of fuel. So liquid, your crude petroleum oil. So your crude petroleum oil is also a fuel, liquid fuel. That is, it might be petrol, diesel, kerosene, all these are liquid fuels. Gaseous fuel. So LPG is a gaseous fuel, your CNG is a gaseous fuel. So all this depending upon the state. So these are classified. So next type of classification. So next type of classification is depending upon the occurrence. So depending upon occurrence, you have two types of fuels. What are those? Primary fuels and secondary fuels. All the fuels which occur naturally, all the naturally occurring fuels are called as primary fuels. So naturally occurring fuels are called as primary fuels. So wood occurs naturally, and I can see in the diagram whichever projected over here. So wood occurs naturally. Your charcoal, the black, your coal occurs naturally. How is coal formed? When a plant and animal remains which is buried under the earth undergoes anaerobic degradation for years together, right? So that will undergo plant animal remains will get converted to the coal, right? So if you leave it further, this coal will undergo further anaerobic degradation for millions of years and will get converted to petroleum products. So this solid material can be used as a fuel. Where it is used as a fuel? In your steam engines, in your thermal power plants to get electricity. So wood, you know where it is used. So coal to in a steam engines it was used. Now it is used in your thermal power plants. Okay, these are your primary fuels. Then what are secondary fuels? Secondary fuels, any substance after processing, if it is used as a fuel, then it is called as secondary fuel. So any chemical substance, okay, after subjecting to a chemical process, if it is used as a fuel, it is called as a secondary fuel. Okay, so for instance, your crude petroleum oil. The crude petroleum oil is a primary fuel. So crude petroleum oil is a pure primary fuel. So that cannot be used directly in your engines. That will be subjected to fractional distillation column, right, for fractional distillation process. So it is subject to fractional distillation column depending upon temperature. Various fractions will separate out. So what are those various fractions? Petrol, diesel, kerosene. So petrol, diesel, kerosene, all these are used as fuels. Petrol and diesel used in IC engines, okay, and in automobiles. Your kerosene is used in here for cooking purpose, right? And if for charcoal, wood undergoes combustion. So once wood undergoes combustion, if it undergoes incomplete combustion, what will happen? The remains of wood, that is charcoal, it can be used as a fuel. Where it is used? It is used for pressing the clothes, right? It was used. Next, natural gas. So natural gas is a primary fuel, but compressed natural gas is a secondary fuel. So you have this compressed natural gas. So you get a natural gas, it will be compressed and be supplied for household purpose. So this is a secondary fuel. So any chemical substance, if it is after some chemical process, if it is used as a fuel, those are called as secondary fuels. So example I have given in different states also. Solid, liquid and gaseous state. In solid state, your charcoal, liquid state, petrol, diesel, kerosene, your gaseous states, your CNG, biogas, etc. Okay. Now the energy is liberated. When you burn the fuel, you're going to liberate the energy. So the liberated energy should be measured, right? So what is the parameter to measure this energy? There should be some parameter, and that parameter is called as calorific value. So before going to that parameter, a small table here you can see. So fuels are classified into primary fuels and secondary fuels. Here you have what do you have? Primary fuels and secondary fuels. So primary fuels are divided into solid, liquid and gaseous. You have the example. Secondary fuels, once again there is a simple example given over here. So now let us discuss calorific value. So the amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen is called as calorific value. What do you mean by calorific value? The amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen. What do you mean by unit mass? It might be 1 milligram or 1 gram or 1 kg. So when a unit mass of fuel is completely burnt in excess of air. Why excess of air? When excess of air is supplied, only the chemical energy which is ever is hidden, it will be completely converted into either heat or light. Their energy transformation will occur. So otherwise the energy transformation will not occur. Okay. So if you have, see, you have carbon plus hydrogen. So what will happen? This carbon and hydrogen, so both will undergo carbon and hydrogen both undergoes carbon will get converted to carbon dioxide, hydrogen will get converted to water, whereas the chemical energy which is hidden there, that gets converted to energy in the form of light or in the form of heat. Okay, so for the complete combustion you are supposed to supply sufficient quantity of oxygen. That sufficient quantity of oxygen is not supplied, then what will happen? Energy will not be liberated. So I have two types, one is GCV and other one is NCV. What is GCV? The amount, GCV is gross calorific value, NCV is net calorific value. So gross calorific value, so the amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen and the products of combustion are cooled to room temperature. The products of combustion are cooled to room temperature. What are the products? The products are carbon dioxide and water. So you have carbon, hydrogen. So this undergoes combustion to give you carbon dioxide and water, right? So here carbon dioxide cannot be cooled. Only thing which can be cooled is water. Okay, so water will be in the form of gaseous state. So this water can be cooled to give you H2O liquid. So when this water cools, when 1 gram of water gas is cooled to 1 gram of liquid, it liberates some amount of energy. So that energy will be taken into consideration. So from 1 gram of water to convert to 1 gram of liquid, it liberates 587 calories of heat. How much? 587 calories of heat. So that heat is also considered here. Therefore, GCV is defined as amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen and the products of combustion are cooled. What are those products? Here, water vapor is cooled to water liquid. Okay, so latent heat. So when 1 gram of water is cooled to get the liquid, some amount of energy is liberated. That energy is called as latent heat of steam or latent heat of condensation. So for 1 gram, how much it is liberated? 587. So this 587 is the latent heat of steam or latent heat of condensation. So then what is NCV? So NCV is nothing but NCV is amount of heat liberated when a unit mass of fuel is completely burnt in excess of air or oxygen and the products of combustion are let off into atmosphere. So what are the products of combustion? The products of combustion are carbon dioxide and water. So both will be let off into the atmosphere. Okay, so we want only the energy which is liberated. This energy only we are going to calculate. Only this energy we want and not the energy liberated by water. So how to calculate this we will see in our next discussion. Okay, thank you.